All right, so today is the first day of our conics unit, and the first conics section we are going to discuss is called the parabola. You've done parabolas in Algebra 1, you've done parabolas in Algebra 2. We're going to do them one more time, but we're just going to beef it up a little bit. So the first thing we're going to have is the definition. A parabola is a collection of all points P in the plane that are the same distance from a fixed point F as they are from a fixed line D. So the point F is called the focus, and I'll show you where it is in the picture in just a second. And the line D is called the directrix. So every single point on this parabola is exactly the same distance from F as it is from the directrix. And we're going to call this distance, we're going to call it the A. And usually when I ask you what is the A, the easiest way to answer it is it's the distance from the vertex to the focus, but it's also the distance from the vertex to the directrix. These two distances will always be the same. And it's going to come in really handy when we're solving. So one more time, if I ask you for A, it's the distance from the vertex to the focus, or it could also be the distance from the vertex to the directrix. All right, so we're going to study 4 types of parabolas. The first 2 that we're going to study are parabolas that open up and down. And all parabolas that open up or down will have a y variable that is not squared. Every parabola that opens up or down will have a y variable that is not squared. So this first equation over here is not solved for y. So if I asked you to solve this for y, the first thing you would do is divide by 4a. And then we'd have y minus k equals x minus h squared over 4a. And then if I said, okay, get y by itself, you tell me to go add k. And that's how we get this equation right here. If you have a positive y equals, it's going to open up. If you have a negative y equals, it's going to open down. The h and the k are going to give you the vertex, so it's where you start your parabola. Notice that this is in the parentheses, so this one's always going to be the opposite. This is outside the parentheses, so it's going to be exactly what it says. So h and k is the vertex, and a, we talked about this a second ago, is the distance from the vertex to the focus, but it's also the distance from the vertex to the directrix. So if I gave you an equation and no calculator, you should be able to identify parts of the parabola. The first thing I'm going to ask you for is what is A? Well, if you'll notice in the formula, the bottom, the denominator, is always 4 times A. So if this is 4 times A, this means 4 times A was equal to 16. So if I divide 16 by 4, we find out that A is 4. Your vertex, remember, is whatever is written in here. I'm going to do the opposite of inside. So this is an x inside, and it's a negative 3. So my vertex is going to be positive 3. And then this right here is going to give me the y coordinate, and you just do exactly what it says. So the vertex is 3, 6. The distance from the vertex to the focus is 4, and the distance from the vertex to the direction is also 4. This parabola is going to open up because it's positive, and then they want me to do a little sketch. And when I say sketch, I really do mean sketch. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, 6. So I've got a vertex right here. Okay, it's going to open up. Your focus will be a distance of 4, and your focus is always inside, so I would go up 4. And your directrix is always outside the parabola, so I would go down 4. 1, 2, 3, 4, and I would draw a horizontal line. That's my directrix. Okay, so let's go do it again one more time. So over here, it's a y parabola again. The x is squared, the y is not, so it's either up or down. Because it's negative, it's going to open down. This bottom number under here is always 4a. So 4 times a is 8. 8 divided by 4 is 2. So my a is 2. The vertex is going to be the opposite x coordinate for what's in the parentheses. So it's going to be negative 3, negative 6. And again, we're just doing a simple sketch. So I'm going to go left 3. Oh, I did this picture wrong. And down 6. 1, 2, 3, 4, 5, 6. It's going to open down. Remember what I said, this right here is going to give me the distance to the focus and the directrix. The focus is always inside the parabola, so I would go 2 in, and then I would go 2 out to get the directrix. I messed up this graph over here. If you'll notice, the vertex was 3, 6, and I graphed negative 3, 6. So that's completely wrong. So let's come back over here. We're going to go graph 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. So there's my vertex. It still opens up. It's going to be 4 inside to get the focus. So 1, 2, 3, 4. 4 outside, 1, 2, 3, 4 to get the directrix. Sorry about that. Okay, so this is what happens when you have a parabola that opens up or down. Again, if it's an up or down, the y will not be squared. So now let's go look at our other two situations when it's not up or down, but when it's left and right. So similar to what we did a second ago, we're going to go solve this for the variable that's not squared. This time the variable not squared is the x. So I would divide by 4a first on both sides. And then I would move this h to the other side, so it would become a plus h. Okay, so notice this time the x is not squared, but the y is. It's still a 4a under here. Where you're going to get confused is, remember, this is my y coordinate inside. So when I go write my vertex this time, it's going to be, this is the x, and it is what it says. This is the y, and I do the opposite. So h and k is still the vertex. That didn't change. A is still the distance from the vertex to the focus, and from the vertex to the directrix. So none of that changed. You'll notice on this equation, though, it says x equals. The minute it says x equals, that means I'm not going up and down, but I'm going left and right. If it's a positive, we go right. If it's a negative, we go left. So this is a positive, so I already know it's going to go right. So I'm going to go ahead and answer that. The bottom didn't change. This is still 4a equals the denominator. So 4 divided by 4 is 1. My a is 1. The vertex is probably where you're going to mess up most often if you do. Remember that now this is your x coordinate, and you do what it says. And this, because it has the y, is the y coordinate, and you have to do the opposite. So the vertex is going to be 6, 3. So if I go sketch this one, I'm going to try to do a better job this time. I go 1, 2, 3, 4, 5, 6, 1, 2, 3. So there's my vertex. This one's going to open right, so I go to this. I'm going to go 1 inside to get the focus. I'm going to go 1 outside to get the directrix. Okay, notice this time it's also a vertical line. All right, let's go do it again. This time I have a negative. X is not squared, so that means it's going to be left and right. Because it's negative, I'm going to go left. The denominator is 12, so I'm going to have 4a equals 12, so a equals 3. The vertex, remember the outside number is my x. The inside number is the y, but I write the opposite. So if I sketch this one, I'm going to go left 6, 1, 2, 3, 4, 5, 6, down 3. There's my vertex. It's going to open left. Okay, I'm going to go a distance of a in, so 3 in, and I'm going to go 3 out, 1, 2, 3, and I'm going to draw myself a vertical line. Okay. All right, so again, we have 4 types of parabolas. Ones that open up and down, and if it opens up and down, it's going to have a y that's not squared. Positives are up, negatives are down. We have the ones that open left and right. The x will not be squared. If it's positive, it opens right. If it's negative, it opens left. For both, all the scenarios, the denominator is always 4a, and a will give you the distance from the vertex to the directrix and from the vertex to the focus. Okay, the last term we're going to talk about is the term called the latus rectum. I know that sounds silly. And the latus rectum is going to be an imaginary line that goes through the focus and is parallel to the directrix. It's going to always have 2 endpoints on the parabola, and it's always going to have a distance of twice the a. So if I ever ask you to find these points, you simply go to the focus and you go 2A in both directions, and you'd label what those points are. And we'll do something like that in just a little bit. Okay, so we are done with vocabulary, and we're ready to do a few examples. So example 1 says find an equation of a parabola with a vertex at 0, 0, a focus at 3, 0. They want me to graph it, give the equation of the directrix, find the 2 points that define the lattice rectum. I'll start just calling that the LR. Anytime I do one of these problems, I always start with a graph. I just work better that way. So it says I have a vertex at 0, 0. So there's my vertex. I'll label it with a V. It says I have a focus at 3, 0. Okay, so right now I have a lot of information just by graphing these 2 points. Remember I said earlier that the focus is always inside the parabola? So I know right now that this is going to be a parabola that opens to the right. I also know the vertex is at 0, 0. So if it opens to the right, I need a positive x equals. If the vertex is 0, 0, it means I don't need any parentheses. So I'm just going to have a y squared. I know this is going to be 4 times whatever a is. Well, a is your distance from the vertex to the focus. So how far apart are those? So a equals 3. So my equation is x equals y squared over 12. Or you could also write a equals 1/12 y squared. Both of those are okay. It doesn't matter which way you write it. You might see it both ways. They also wanted me to graph the directrix and write the equation. So this is the equation of the parabola. My directrix is going to be the exact same distance from the vertex. So if I went 3 right, I'm going to go the opposite direction, and I'm going to draw a line right through there. That's my directrix, and the equation of that line is x equals -3. So there's my directrix. And they want me to find the 2 points that make up the LR. Okay, so to find the LR, you go to your focus, and I'm going to go distance of twice A so that I lie on the parabola, which means I'd have to go 2A this way and 2A this way. Okay, so if I'm at the point 3, 0, and I went up twice A, so 2A would be 6. So if I went up 6 from here and down 6 from here, I would be at the point 3, 6. If I went up, and if I went down, I'm going to be at the point 3, -6. So that's an LR, and that's an LR. Okay, well, that's just one example, so let's go do another one. Okay, example 2. This time they gave me the equation, and you're always going to solve for the equation that's not squared. So if I solve for the letter that's not squared, I'm going to solve for x. That says 8 times x. I'm going to divide both sides by 8. So x equals y squared over 8. Because it says x equals, I know it's going to open left or right. Because it's a positive, I know it's going to open to the right. Because there are no parentheses, I know that my vertex is going to equal 0, 0. Again, my a, just like the front, the bottom number is my a. So I know 4a equals 8. So a is equal to 2. Okay, so I'm going to go ahead and graph this. I need a point at 0, 0. It's an x equals, so I know it's going to open to the right. So I'm going to go right 2, because that's my a. And that would be my focus. I'm going to open right. I'm going to go left 2 to get the directrix. And that's x equals -2. I'm going to label that the directrix. Okay, so what did they want from me? They want me to graph it. So there's my graph. They want me to find the focus. So the focus was at the point 2, 0. They want me to write the equation of the directrix, x equals -2, and they want me to find my 2 LRs. Okay, so I go to my focus, and I'm going to go twice A so that I land on the parabola. So I'm going to be here. There's one LR. If my A is 2, 2A would be 4. So I'm going to go 4 up, then I go 4 down. So if I'm at the point 2, 0, and I go 4 up, I'm at 2, 4. And if I go 4 down, I'm at 2, -4. Okay, that's example 2. Example 3. Same type of problem, but this time the y is what's not squared. So that says negative 12 times y, so I divide by negative 12, and we get y equals x squared over negative 12. And I like to just put my negative out front. So because it's a y equals, it's an up or a down. Because it's a negative, it opens down. So I know it's going to open down. I also know, because there's no parentheses, that my vertex is going to be at 0, 0. I know that 4a equals 12, so a equals 3. Okay, so I'm going to go ahead and graph now. I have a vertex at 0, 0. It's going to open down, so I go 1, 2, 3 down. That's my focus. Remember, the focus is always on the inside of the parabola. I'm going to go the opposite way, 1, 2, 3 up. And there is my directrix, and that equation is y equals 3. Okay, all right, so they want me to find the graph. There's my graph. Find the focus. So the focus was at 0, negative 3. The equation of the directrix was y equals 3, and they want me to find my two LR points. Okay, so this time, since my parabola is opening down, I'm going to go twice my A. So twice my A would be 6, but I have to land on the parabola. So I'm going to go 2A this way, so I'm going to go 6 to the right, and then I'm going to go 6 to the left. Okay, this point right here is 0, negative 3. If I go 6 to the right, I'm going to be at 6, negative 3. And if I go 6 left, I'm going to be at negative 6, negative 3. Okay, so I hope that made sense. Let's go look at example 4. So on example 4, it says find the equation of the parabola with a focus at 0, 4. So I'm going to go graph it as they give me the information. So 0, 4. 1, 2, 3, 4. There's my focus. And a directrix at y equals negative 4. So 1, 2, 3, 4. Okay, so because my focus and my directrix are going up and down, that's going to tell me that it's going to be a y equals. I also know that in the very middle of this is the vertex, and if I wanted to find the middle of positive 4 and negative 4, I would say it's 0, 0. So my vertex is 0, 0. The focus always has to be inside, so it's going to open up. I know that the distance between these two is my A. That means A is equal to 4. Okay, so I have everything I actually need now to write the equation. Because it opens up, it's going to be a y equals. It's at 0, 0, so I don't need any parentheses. My A is 4, and under here is always 4 times A, so 4 times 4 would be 16. That's it. So a lot of times just drawing the picture helps you get your equation. All right, example 5. Find an equation of a parabola with a vertex at 0, 0. Okay, so I know there's not going to be any parentheses, 0, 0. Its axis of symmetry is the x-axis. So if this is my axis of symmetry, that means it's either going to open left or it's going to open right. That means it's going to be an x equals equation, so I know that. And they tell me the parabola is going to contain the point negative 1/2, 2. So negative 1/2, 2 would be right there. That means my parabola is going to open to the left. So now I also know that because it's at 0, 0, and it opens left, I'm going to have a y squared, which is negative, over 4 times A. They didn't give me the focus. They didn't give me the directrix, so I have no clue what A is. So we're going to have to do something different. I'm going to use this point right here, and I'm going to plug in negative 1/2 for my x, and I'm going to plug in 2 for my y, and I'm going to solve for A. So I'm going to have negative 1/2 equals negative parentheses 2 squared over 4A. I took the x and I plugged it in here. I put the y right here. So I have negative 1/2 equals negative 4 over 4A. I'm going to multiply both sides by the denominator. So I'm going to have negative 1/2 times 4A equals negative 4. Negative 1/2 times 4 is negative 2. And then I'm going to divide negative 4 by negative 2 and find out that A is equal to 2. Okay, now that I know that a is equal to 2, I'm simply going to go plug it in right here. So x equals negative y squared over 4 times 2 is 8. Those are a little bit harder. You won't have a lot of those to do, but you do need to understand and be able to do them. All right, last example. All right, find the equation of a parabola with a vertex at -2, +3, -2, +3, and a focus at 0, 3. So vertex, focus. Okay, so I know I opened this way. Because I open to the right, I'm going to have an x equals, and it's going to be positive. But this time, my vertex is not at 0, 0. So that means I'm going to need parentheses. Remember, your y coordinate is going to go in here. So I'm going to do the opposite. Out here is going to be my x, exactly what it is. And down here is going to be my 4 times my a. But don't freak out, because this time we actually know a. Remember, a is the distance from the vertex to the focus. So if this is at -2, 3, and this is at 0, 3, my distance right here is 2. So I just need to go plug in a 2. So x equals y minus 3 squared minus 2 over 4 times 2 is 8. And you're done. So, oops, I was wrong. We have one more example. Actually, I'm going to table this one, and we're going to do this together in class on Monday. So Monday. So what I'm going to do now is you're going to get the worksheet 9-2 in class, and I'm going to assign a few problems, and we're going to work on them on Monday. So don't stress out about it right now. Just know that on Monday we're going to work some of these problems together. Okay.